Okay, so section 8.5 continued. Hopefully you gave this one a shot yourself for expanding and contracting. So we're going to expand this out, and we should have gotten a squared plus a plus 1 quantity squared. That means a squared plus twice the product of these, which is 2a, plus the 1 squared, which is 1. And then I'm going to add this a to both sides, so plus a here. And then that's going to be equal to 0. And then I'll combine the like terms. So I have the a squareds and the a squareds combining to give me 2a squared. And then I have the a here and the a here combining to give me 3a, and then plus 1. Now remember, when the leading coefficient's not 1 but the constant is, that's kind of the same principle as when the leading coefficient's 1. So I am looking for the factors of 2 that sum to 3. So I have a 2a and an a. And these are both going to be pluses since how sum and it's a positive, so those are both pluses, and remember the factors of 1 here and here. And so that's how that one factors, and you can check it out if you want, right? 2a squared, 2 plus 1, and then 1s. And so now we're going to set each of these factors that contain a variable equal to 0. So 2a plus 1 equals 0, or just a plus 1 is equal to 0, and then we'll solve. So I'm going to add the opposite of 1 to both sides, so 2a is equal to negative 1, and then multiply by the reciprocal here and here, so a is equal to negative 1/2, and then here add the opposite of 1 to both sides, and so I get a is equal to a negative 1. So either a is equal to a negative 1 or a is equal to negative 1/2. And I'll let you check those on your own, but hopefully that's what you got in the first place. And so those would be our solutions. And now we're going to move on to some polynomial functions that aren't quadratic equations. These have higher degrees than just a second degree. These will require us to use some of our strategies of factoring by grouping and or just factoring a GCF. So in this first one, we're going to have to expand this out before we can do anything. Oh, I missed that one. Sorry, I had misspoke. This is still just one of the last ones we were doing. So let's go ahead and finish this one out. This is not one of the factoring by grouping strategies or GCFs. This one is still just an expand. So we have a 2y squared minus a 10y, and then minus 12 is equal to 0. And I think we did one like this before. We factor out that 2, leaving y squared minus 5y minus 6, which is equal to 0. And then we factor this polynomial here. So we have 2 times, and we have a y, and we have a minus 6, and y plus 1. And then that's equal to 0. And we'll set each factor that contains a variable equal to 0 and solve. And so remember the 2 does not contain a variable. So because this doesn't contain a variable, you don't set it equal to 0. And now we have add 6 here, and y is equal to 6. Add negative 1, add a negative 1, and y is equal to a negative 1 here. And so those would be our solutions, this or this. And we might as well go ahead and check that really quickly. 6 times 2 is 12. 12 minus 10 is 2. And 2 times 6 is 12. 12 equals 12. Excellent. Negative 1 times 2 is a negative 2. Negative 2 plus negative 10 is a negative 12. And a negative 12 times a negative 1 is a positive 12. Check. We've got the solution. All right, now moving on. These are the ones that I was saying before. These either have a GCF or they are going to use factoring by grouping, and we're going to have more than 2 solutions in these cases. These are polynomial equations of higher order than second, and so we can have more than 2. In fact, the most solutions to a polynomial equation that you can have is the degree of the polynomial. So a second degree, you could have 2 solutions, or you could have 1 solution, or you may not actually have any. We'll see a bit later on. And with a cubic here, third degree equation, we could have 3 solutions, or we could have 2, or we could have 1, or possibility of none. We'll come back to these in the next video to solve.